Voyagers are sending back frightening information to Earth. The Voyager 1, NASA's farthest voyage rocket, is still traveling across uncovered areas of the universe almost 50 years after its launch. Researchers are confounded by the startling data that this well-known space probe is sending back to Earth due to what seems to be a breakdown. Join us as we discuss the strange information that the Voyager has been communicating back to Earth during its sensitive space investigation venture. Researchers have been intrigued by studying the domain beyond since the Big Bang, and that is what inspired the launch of Voyager 1 and Voyager 2, among other space missions. Voyager 2 was actually the first shuttle to launch, leaving from NASA's Kennedy Space Center on August 2 SD, 1977. On September 5th of that same year, Voyager 1 was launched about 2 weeks later. However, how did they switch places? As twins, the weight of the two probes is around 720 kilograms, about the equivalent of a small vehicle. Both were launched during a window of extraordinary outer planet arrangements that caused a slingshot effect to launch the shuttle from one planet to another. They have, however, needed to move at different paces and in different directions. On December 15th, 1977, Voyager 1 was able to pass its identical twin along the way, and from that point forward it has been our go-to resource for learning about different realities in space-related enigmas. The first shuttle to do so was this one when it began its Jovian imaging mission in 1978. It was nearly 265 million kilometers from our planet and sent a huge number of photos back to us. Voyager 1 completed an extraordinary 108-hour stretch starting in January 1979, during which it captured 3,750 pictures of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's turns it had gone through the Jovian moon system in February 1979, and after a month it had discovered the small ring surrounding Jupiter. Voyager 1 also made a unique discovery when it found 2 new moons named F and Neos. Right moves were made to ensure that the spacecraft was prepared for its flyby of Saturn and to prevent a potential impact with Titan, one of Saturn's moons. Voyager 1 also discovered 4 other moons during its orbit of Saturn, including Mimas, Enceladus, Tus, and Dione. Researchers chose to stop the Explorer planetary mission after the Saturn mission was finished and sent both Voyager 1 and Voyager 2 beyond our planetary group at a speed of 325 million kilometers each year. In January 1990, the new mission, formerly known as the Explorer Interstellar mission, began. Some of the most renowned photos in history portraying the Sun and the majority of the planets were taken by Voyager 1 on February 14, 1990. While it was 6 billion km from the Sun, they are regularly referred to as the Solar System family photograph. There were 60 total shots taken by Voyager 1, bringing the total number of photographs taken by the spacecraft to 670, despite the fact that Mercury and Mars couldn't be seen in the photographs due to multiple factors. The space probe's cameras were turned down to conserve power and memory before its journey to interstellar space. Moreover, in addition to the interstellar probes, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Voyager 1 passed by the Trailblazer 10 on February 17, 1998, the Pioneer 10 was the farthest spacecraft. Voyager 1 continued its journey for a further 14 years before it finally arrived in the interstellar environment on August 25, 2012, with no other space probes to be seen. NASA didn't publicly announce the achievement until 2013. We moved to November 2018, when both space probes had officially left the nearby planetary group, with Voyager 2 crossing the heliopause and entering the Interstellar medium Voyager 1 is thought to be 145 billion miles, or 550 million. Kiln from Earth, it has continued to give us significant data that no other space probe missions have been able to reveal. Since it entered the unseen domain, beyond our planetary group, the spacecraft has spent the majority of its 45-year journey in space in good health. However, lately scientists have discovered some odd anomalies in its performance. Voyager 1 is currently communicating baffling signs back to Earth, giving the impression that it is uncertain of its location coordinates. There is, however, a startling twist to the issue. Typically, researchers have pre-programmed Voyager to go into safe mode or sound an alarm if it gets derailed in space, yet up until this point it has not. Furthermore, its antenna, which communicates data back to Earth, appears to be in great working order. However, the data it has recently been communicated is unclear. The Interstellar Pilgrim is working routinely, taking instructions from Earth and carrying them out, as well as gathering and communicating scientific data. However, readouts from the spacecraft's explanation and control system do not precisely reflect what is occurring inside. According to a NASA official statement, what precisely is happening on board each spacecraft that is heading toward interstellar space, including Voyager 1 and 2, has an extraordinary 12 inches wide gold-plated disc stacked with sound and video messages as a backup in case an alien species finds a craft. It includes 35 Earth noises, 115 live photographs, 90 minutes of Western music, and good tidings from former U.S. President Jimmy Carter and former Secretary General Kurt Waldheim. These are just a few of the items on the space DVD. Moreover, they are kept in 55 different languages, so if the spacecraft were taken over by outsiders, they would probably be attempting to interpret the signal. Speculations that the spaceship is currently under the control of aliens have been quickly dismissed by researchers. Voyager ability to operate depends heavily on the attitude and orientation control system. First off, it always keeps its antenna focused on the planet so that scientists can accurately receive information. Furthermore, it controls how the spacecraft is positioned. Engineers keeping an eye on the situation now feel that the attitude control system is working as it should, which only adds to the puzzle we currently face. Additionally, none of the safety features designed to protect the rocket from danger have been activated. According to Susan DoD, project manager for Voyager 1, such a mystery is not all bad at this point in the Explorer mission. The spacecraft are both around 45 years old, which is much older than what was envisioned in the mission plan. Dodd also acknowledges that the spacecraft's engineering team will face significant challenges in solving the issue with Explorer 1 due to the distance between us and the spacecraft. The challenges are immense, largely due to the rocket being around 145 billion miles away from Earth. This vast distance presents a number of inconveniences that the team must navigate carefully. A rescue operation is nearly impossible, given the current technological and strategic constraints. Explorer 1 is far beyond the range of any spacecraft or repair mission that we could realistically send. The spacecraft's amazing journey has brought it into the farthest areas of our nearby planetary group and beyond into interstellar space, where it continues to travel further away from us. Everyday messages received from Earth at the speed of light take almost 21 hours to reach Voyager 1's current location. This means that any order or instruction sent by the engineering team takes a considerable amount of time to be received by the spacecraft. This delay poses a significant challenge for ongoing troubleshooting and investigation. Moreover, once Voyager 1 processes the order any response or information it sends back to Earth will take an additional 21 hours to return this. Suggests that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it especially difficult to implement practical solutions or iterative troubleshooting processes, which are often essential when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating different scenarios and potential outcomes. Unlike missions closer to Earth where specialists can quickly send and receive orders, the long communication delay requires a more strategic and patient approach. Every instruction must be carefully designed to address the known issues without causing additional problems, given the extended time it takes to confirm whether the order had the desired effect. The critical communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be successful and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are sent to Voyager 1. In addition to these strategic challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, though cutting edge at the time, is now considered outdated by modern standards. The engineering team must work with hardware and systems that were designed and built in the 1970s, which adds another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant wear and tear on the spacecraft systems. Voyager 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remain as committed to resolving the ongoing issues. They are investigating various theories about what may be causing the anomalies and testing potential solutions through simulations. On Earth, this careful, calculated approach is crucial, given the stakes involved. Any wrong command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Voyager 1 systems. Like many other space missions, Voyager 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems and restore normal operations if they confirm that a specific component is failing. In summary, while the challenges of diagnosing and fixing the issues with Voyager 1 are immense, the engineering team is using their expertise, experience, and the spacecraft's inherent resilience to address the problems. Their careful and patient approach is essential in handling the critical communication delay and the complexities of working with a spacecraft that is both extremely distant and thoroughly aged. Despite the odds, their efforts aim to continue Voyager 1's legacy of exploration and scientific discovery far beyond its original mission boundaries. The breakdowns may be the result of cosmic rays altering some of the spacecraft's delicate electrical systems. These high energy particles originating from distant supernova or cosmic events travel through space at nearly the speed of light. When they strike Voyager 1, the particles can penetrate its exterior and affect internal electronic components. The longer the spacecraft remains in space, the greater the likelihood that cosmic rays will impact its systems over time. This phenomenon can lead to irregular anomalies like the ones currently seen in Voyager 1's telemetry. Data engineers have long been aware of the potential risks of cosmic rays to spacecraft devices and even human explorers. However, the extent of their impact can be difficult to predict or mitigate despite these challenges. Engineers have implemented various measures to shield spacecraft from cosmic rays, including protecting sensitive devices, designing redundant systems, and using error-correcting codes. In data transmission, even with these safeguards, cosmic rays can still pose a threat, especially to spacecraft operating in deep space for extended periods, as in the case of Voyager 1. Although the current abnormalities in Explorer 1's data are puzzling, they are not entirely unexpected given the spacecraft's age and its prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze the data received from Voyager 1. They are working to determine the exact cause of the anomalies and develop strategies to mitigate their effects on the spacecraft's operations. Despite these challenges, Voyager 1 has far exceeded its original mission expectations and continues to provide valuable insights into the outer regions of our planetary system and beyond. Its achievements are a testament to the ingenuity of its creators and the dedication of the team that has supported it for over 40 years. Voyager 1's journey is a symbol of humanity's enduring curiosity and determination to explore the unexplored reaches of space. As we look to the future, missions like Voyager 1 will continue to inspire and expand our understanding of the universe